We will start in 2 minutes, so make yourself comfortable, grab a coffee or tea. We are heading into a very interesting discussion, the web talk of the German Center for Research and Innovation. My name is Katja Lasch and I am the director of the center, and I also welcome our panel and our moderator of today's session, which is the opening session of a web talk series where we are dealing with artificial intelligence for sustainable development goals. AI is one of the key technologies shaping the future and is already altering the world. Everybody is talking about AI, but sometimes I have the feeling when I talk to people, everybody is mentioning it as a buzzword. But if one looks a bit more detailed, things are not so clear. And I hope we achieve with this web talk series to discuss AI, discuss current developments in India and Germany, discuss international cooperations, and to offer a good insight into exciting ongoing research and developments in AI, not just in agriculture. Also want to mention we are going to deal tomorrow with health and on Wednesday with education. Governments around the world are developing national strategies, and we've seen India and Germany in 2018 pushing up national strategies for AI, where also substantial funding is provided by public bodies. And I just want to mention that the German government funds currently 6 centers of national importance in AI, and we're going to have one expert of these centers in day 3 of our web talk series from the German Center for Artificial Intelligence. At the moment, Germany is also attracting 30 international scientists through a prestigious scholarship program, the Alexander von Humboldt Fellowship Program, to come to Germany to teach at universities and to do research in AI at universities. And last but not least, Germany is looking into international cooperation. We have been setting up international future labs, 3 of them, and I'm very proud that we have tomorrow an expert from one of these future labs on our panel on health. As I mentioned, these are labs who are dedicated to international cooperation in AI, and we have numerous other projects which are funded these days in Germany. But it's not just Germany, it's also India. So India announced this March to establish national centers in artificial intelligence. We have initiatives on the federal level, but also on the state level. We have public-private partnerships in India. And tomorrow we're going to have one speaker from the INAI, which is a center set up together from the IIIT Hyderabad and Intel. And last but not least, we have today with us Jibu Elias. And let me introduce our moderator of today's panel, who is heading one of the important communication projects on AI in India, the National Portal for AI India. Jibu, welcome today, and thanks for accepting our invitation for doing the moderation. But it's not just the government, it's also private investments. We will see this in this web talk series. We look into large projects which are done together by research institutions. And tomorrow we're also going to have on the panel Gerd Höfner, who is representing Siemens in India. So creating better solutions for societal goods with the help of AI is discussed in the context of this web talk series. We decided to focus on 3 sustainable development goals: quality education, good health and well-being, and zero hunger. These topics are addressed from perspectives of developing as well as developed countries. And I'm very glad that over the next couple of days, we have experts, decision makers, and professionals from Germany, India, but also Switzerland and Japan on our panels. We, as the German Center for Research and Innovation, are an umbrella organization of 18 organizations, universities, and funding bodies in India. We are funded by the Federal Foreign Office of Germany, and the management is done by the German Academic Exchange Service, better known in India as DAAD. Our scope is to promote the German research landscape and to enhance research cooperation between India and Germany. And for that, information, discussion, networking is always the first step. And that's what we are going to do over the next 3 days. So we are a platform for exchange and networks. We are addressing different topics, reaching from AI. We've been working a lot on citizen climate currently, but also looking into the field of international entrepreneurship. I want to mention that this event is meant to be an interactive event. That's why we're running it as a live session. It's not a recording. So please feel free to take your questions in the chat. We will take them up in the discussions a bit later. And additional information on the Indian and Germany AI initiatives will be posted in the chat. And I see the colleagues already active there, but can also be found on our website. As mentioned, we have 2 more web talks in the series. I want to mention that tomorrow we are dealing with health. Experts from India, Germany, and Japan will look into AI for targeted medicine, modeling in pandemics time. I think a really, really important topic these days, diagnostics and hospital management. And on our panel at the third day, Wednesday, we will discuss into software development and applications for school and higher education, covering topics such as mentoring, school dropouts, student assessment, and the students' learning journey. Registration is still possible for these 2 days. I want to take the opportunity also to thank, first of all, my team, but also to our partners for this web talk series. We partnered up, and especially for this web talk, with India AI and the Bavarian Indian Center, but partners over the week are also SwissNex India, which is a Swiss organization, and the German Center for Research Innovation in Tokyo. So I'm looking forward to an interesting and engaging discussion. And I hand over now to GB Olias. I introduced him already. He is heading the India AI portal, where you can find a lot of useful information, everything with regard to AI in India, I would say. And the portal is run by the government of India, NASCOM, so a perfect example for a public-private partnership. And I would hand over to you, Jibu, and I think you will take over and will present our panels of today.
Thank you very much, Katya, and rest of the team for organizing this web talk. And good afternoon to everyone here, their panelists, as well as the participants who came here to attend this web talk. I like to call artificial intelligence a civilization-altering technology, such as fire or electricity. And agriculture will be one of the critical sectors that will be influenced by this technology. As we know, agriculture is the backbone of many economies, any economy in the globe. Agriculture development is one of the most powerful tools we have to end poverty, boost shared prosperity, and feed a projected 9.7 billion people by 2050. Growth in agriculture sector is in a way 2 or 4 times more than effective in raising incomes among poorest compared to the other sectors. And in many analysis happened in recent years point out that 65% of poor working adults made a living through agriculture. Now coming to India, it's much more important. Agriculture is one of our primary sector, and more than 50% of India's workforce is employed in agriculture sector, while it contributes 18% to the total GDP of the economy. India ranks second worldwide in agriculture production, and 58% of the population in India, agriculture is the primary source of their livelihood. And agriculture doesn't end being a economic part of the GDP. It is demographically the broadest economic sector and plays a significant role in the overall socio-economic fabric of India. However, this sector has been plagued by many serious issues as underemployment, outdated farming techniques, exploitations by middlemen, in access to proper markets, a lack of credit, changing weather patterns, among several other challenges. And not to mention other challenges such as how climate change could cut crop yields, or especially in world's most food insecure regions, and how agriculture, forestry, and land use changes are responsible for about 25% of greenhouse gas emission. So mitigation in the agriculture sector is a bigger part of the solution to climate change and a sustainable future. But with the advent of data, IoT, machine learning, computer vision, and other AI technologies, we have been witnessing a new wave of tools in this domain that deployed on larger scale could be a transformational force in our quest to address food security, environmental challenges, and a sustainable future. So as the first of the series of this AI web talk, today we are here to discuss the role of AI in agriculture, and we have a panel of 3 brilliant speakers, Professor Sonoko Dorota Bellingrad Kimura, who is the head of the research area 2 land use and governance at Libin's Center for Agriculture Landscape Research, Dr. Sebastian Bosa, who is the head of interactive and cognitive systems group at Fraunhofer Heinrich Hertz Institute in Berlin, Germany, and Ramkiran Dulipala, who is the team leader of agriculture, of digital agriculture and youth team at ICRISAT in Hyderabad, India. So we will open with a brief keynote by each speakers. You can drop your questions through the chat and we will address them as many as we can after the keynotes are done. So let me start with the first keynote, which is from Professor Sonoko. Let me introduce her. So since 2018, she is the co-head of the research area to land use and governance at Libin's Center for Agriculture Landscape Research. She also holds a professorship in the field of land use systems at Humboldt University in Berlin since 2015. Her research extends into topics to the temperate regions, where she examined various land use at the aggregate, landscape, and regional level. Among other things, she now coordinates Agriculture of the Future, the Digital Agriculture Knowledge and Information System, or the DAAD project, in which she and her colleagues develop new field controls based on modern technologies. So I welcome Sonoko to give us a brief overview of her work and talk more about the DAAD technology to us. Over to you, Dr. Sonoko.
Thank you very much for the invitation. Hello to everybody. It's great to have a talk to you on our project Digital Agriculture Knowledge and Information Systems regarding on the agriculture of the future. So we are facing now a lot of challenges in the global change. Several SDGs are involved, as well as the challenge can provide a chance. So we are looking for the chance. It can be new market values, new sensors and models can be developed, new small-scale and site-specific management systems can be developed, new operation models, new cooperation. Regardless of the size of a farm or type, it can be related to this kind of new chances, which also highly relate to the challenges. So if you imagine agricultural landscapes, first there's nothing, and if you imagine and develop from zero, we developed a vision how the agriculture system of the future can be. So it should be especially and functionally diversified. It should diversify systems that allows harmonizing diverse land use and goals. So it depends on the geography, on the farmers, on the history, on the culture. Here is a diagram showing that it can be small fields, but also large fields. And also it depends on the site where you, for example, here you can target for biodiversity, frog production, animal production, system with robots, but also with agro-photovoltaics, and they can be very diverse. So, and now the question is how to deal with this diversity. Here we come to this AI, and I go right away how we do it in our project. So here's an example where we analyze a lot of spatial data, geodata about soil, slope angles, soil conditions, solar radiation, and much more information that are aggregated in the field. So it is it's an example of a 7-hectare large field near our institute. It's a small size for our region, but it is very heterogeneous. So it is 1 pixel can be few meters, and this from soil types as well as the potential of the yield, it's very diverse. So creating this kind of map, we can do it statistically, but also with high use of AI. So it's as I said, machine learnings and so on. Another type where we use the AI will be to identify hotspots. Here is an example of erosion. It's also combined with some models. Again, there are different geodatas, and it varies throughout the years with various satellite pictures and land use histories and land use that can be in the future. And based on that, we can identify hotspots. And based on that, the next step will be also again to identify the optimal use for this, how to deal with this small patch within a field, whether you use it as a different land use, put it set aside, or you segregate the field into different field sections. So there will be a lot of options how to use this database, again, with use of AIs. Another one is, again, it's a connection of data. So, you see, I will show you examples based on our expertise. We are on the land use and agronomists, and we use the AI as a tool to develop optimal management options. So in this case, we aggregate these different satellite pictures and develop a graph of landscape heterogeneity and how it should be, how it's developed in the past, what are the rules behind, and how it can be developed and optimized to reach this our vision of this heterogeneous and site-specific land use systems. There are also different aspects. As I showed you at the beginning, there are a lot of challenges, and biodiversity is one big topic in German agriculture because of the large field and homogeneous use, large machines. So we have faced a lot of losses of biodiversity, where the agriculture is one main reason for that. So we analyze with drones and satellite pictures, field images, and ground truth points, detection model about species that we can detect rare species as well as for habitats, and they make a classification how the land use have an influence and how we can change the management system to improve those biodiversity. So these are all fragments. To give you a glance of what we are dealing with, it's a just half time of our project. We now know what's the problems, we know the compartments, and now it's a tricky part to put them all together. So there are different compartments, scenarios, and models, and different information of different qualities. And then our goal is to have a decision support system for farmers, as well as a sustainability impact assessment for policymakers to show what if you are doing like this, you end up with this kind of environmental loads. So these are our current situation. Now we have the compartment, and now the challenging part is to have a front end. It should be a very user-friendly a front end with a GUI, a graphical user interface, but as well as this complex compartments, which I showed you just a glimpse about those aspects from production, erosion, biodiversity, and other aspects which I didn't mention, that goes all together and give you the best answers, or the option of the best answers. It's not the one ultimate answer, but there are several answers depending on the circumstances and background. So there will be several answers, but it should support to deal with this complexity of agricultural landscapes. That is not easy, and it's still not easy also using AIs to make it comprehensive, but our attempt is to connect those data and give a holistic decision support tool. So this DAAD is a one kind of tool now on developing. I think within this year I can show you more results based on literatures, but you can also have a look at the DAAD website, where we introduce our process. And this technical conceptual interdisciplinary integration of is a challenge. And we also need a social transition towards the collaboration of solution. It's not it's a tool, so it has to be used to be further developed. And so it's making a step towards this right direction. And I am very glad to have this interaction with you, and I'm very welcome to discuss this part also with all participants. Thank you very much.
Thank you, Professor Sonoko. That was very insightful, and it's quite refreshing to see how AI technologies can be used to address some of the critical environmental issues such as erosion and etc. and biodiversity. It's very innovative and insightful. Now coming to our second speaker, Dr. Sebastian Bossa. Sebastian Bossa is heading the Interactive and Cognitive Systems Group at Fraunhofer Heinrich Hertz Institute in Berlin, Germany. His current research activities center around computational perception and cognition, machine learning, computer vision, human-machine interaction, and cover a wide field of applications ranging from multimedia, augmented reality, medicine to agriculture. I now invite Dr. Sebastian Bossa to give a brief overview on the sustainable agriculture cloud-based platform for an AI platform called Nalamki project. So over to you, Dr. Sebastian.
So thank you for the kind introduction and for the invitation. So the project I'm going to present is called Nalamki. It has German abbreviation for Nachhaltige Landwirtschaft mit KI, which basically translates to sustainable agriculture using artificial intelligence. I think now you can see my slides as well. And I would like to start with a very high-level system overview that also is able, I hope so, to present the basic idea. So in our approach, we subdivide the system that we are envisioning and that we are going to build within this project into 3 different sort of system layers. So we have the high-level system here that you can see exemplified with this cloud here. And then below that, we have the farm level system. So this is basically one farm, one productive unit within the agricultural ecosystem. And then below this farm level, we have the machine level. This is where the actual work is done. So we have sensors there in terms of drones, in terms of irradiation sensors in the soil, and also camera-based sensors, for example, on the machines running on the farm. And what we want to do now is and we have actors obviously as well, because we want to enable the machines to run autonomously in the near future. And all these things are running on a farm, on an individual farm. And one of the challenges that we met during the planning phase of this project was that there's some sort of hesitation with the farmers to share their data. So what we want to implement is basically a set of different local AIs where farmers can share the data, don't need to share the data, but they just feed it to their local system. And then the local system informs, using approaches like federated learning, informs all the other farms using the central AI machine, the Nalamki system, which is here illustrated as the large cloud. And by that, we envision to guarantee some sort of data sovereignty for the individual farmers. So this is our 3-level approach, and then the basically the overall system is designed in an open and discrimination-free manner, based on the German the European DWIH initiative, so that it basically allows all other actors, third parties, to plug themselves into the system to provide data, to provide AIs services, or to access the data that is lying in there within the system. So this has several applications that are directly usable within the agricultural ecosystem. So on the machine level, obviously, we are going to develop advanced methods of autonomous robotics and predictive maintenance as well, remote control, but also rather simple things that can benefit from shared data like sensor calibration. On the farm level, we will aim at facilitating the documentation process. All these efforts that farmers, at least in Germany, and I think worldwide, have to take care of. We will provide farmers with AI-based analysis and analytics, very similar to what we saw before, with smart recommendations for some sort of interactions with the production system. And then on the system level, we will build a system as a service, AI as a service platform, where people, as I said before, can just plug in their own solutions and consume services that are implemented already. So this is a growing initiative, and even after 3 years, when this project is finished, it will still be in development because, as I said, people can just use it and plug themselves in there. To implement this, we have a set of demonstrators that are coming from the physical layer, like on-site 5G site-link communication that enables us to have the, for example, drones directly communicating with some sort of aerial machines. We will implement this in a DWIH compliant cloud infrastructure to guarantee this data sovereignty as well. And then we have different levels of data acquisition. We have satellite data and drone data, and so we need some sort of multi-scale remote sensing and data acquisition process that we're going to implement. And then on the application layer, so to say, this allows us to build systems for autonomous inspection of fruit plants and for automatic detection of plant infections, like fungus infections, and this in a distributed manner as well, taking into account multi-agent robotics. And in the end, so what's happening there, and what the real benefit is then that we this allows us, for example, for precise control of pesticide output quantity, which will have a huge impact as well on the economic side, but also on the ecologic side. So this is where sustainability actually enters the project, and all of this will be visualized in a very intuitive and natural way, similar to what we saw before as well for the agricultural practitioners, for the farmers. On my last slide, I just quickly want to mention the consortium that's doing all this work. So we have different application partners and manufacturers. So the biggest one is John Deere. I guess all of you know them. Then we have Robot Makers, which is a small startup specializing in agricultural robotics in Kaiserslautern, Opto-Precision. They are building drones and drone-based camera systems. Planet is a company that actually shoots satellites into the orbit and provides us with satellite imagery. We have NT AG, and they're experts for Gaia X and for system-level implementations. And then we have a lot of research partners like the Julius Kühn Institute. They're doing a lot of work in remote sensing as well. University of Hohenheim, they have a new professorship there for AI in agriculture. Kaiserslautern with Professor Berns, he's an expert in robotics for AI. And then our colleagues from DFKI as well, and us, Fraunhofer. So we just kicked off the project basically in February this year. And right now we're in the sort of conceptual phase and are beginning to enter the actual research and development phase. And I'm very much looking forward to this project because it has a lot of potential. It's very, very interesting. Thank you.
Thank you, Dr. Sebastian Bosa. It's quite interesting, how it is building on top of what Professor Sonoko has mentioned, which gives you an overview of farm, how you manage farm through AI. Now the Nalamki project is a little bit in another step when it brings together the different stakeholders and build the whole platform with an ecosystem partners and everyone else. Now, thank you for all the questions. Keep the questions coming. We will address most of the questions. But before that, let me go to Ram Kiran Dulipala. So Ram Kiran Dulipala and youth at AgriSat Hyderabad. He has worked in executive positions in corporate sectors, in fintech, finance, corporate strategy, program management, M&A across diverse sectors. In his current role, Ram drives action research on the use of digital technologies in agriculture and has been instrumental in strategizing and executing private sector partnership based approach towards digital agriculture. Over to you, Ram.
Sure. Thanks, Jibu, and thanks to the earlier presenters as well. I think they set a great context. So this, let me jump straight to. Are you able to see my screen? Just a word of confirmation will be good, Jibu.
Yes, Ram. Yes.
All
yes.
right. Yeah. Thank
Perfect.
you. Yeah. So I will approach this in a slightly different way. Okay. Yeah. Can you see what I've tried to do here is try to give more a broad thematic focus around the use of AI in agriculture, right? From my perspective, all these technologies, be it IoT or remote sensing or mobile data or unmanned aerial vehicles or drones, right? These are all data reconnaissance devices, right? These all acquire the data. Once you have the data, combining the data and repurposing that using AI and ML to answer specific use cases, that's where I think the real magic of AI or ML is, right? And that I've tried to answer it through these. So broadly, we believe that there are about 5 thematic areas where AI and ML will make a deep impact in agriculture. And one of the first areas, of course, happens to be agriculture extension. globally, most people who have been in agriculture know that agriculture extension has largely been a very manual, a very human, intensive process, right? And for countries like India, which are challenged for resources, we can't just hire, more number of people just to ensure that, all the farmers, all the smallholder farmers receive sufficient extension, right? So that's where, digital technologies in general can significantly deliver a lot of impact, especially in the realm of agriculture extension. And specifically coming to, AI and ML, they can really, cater to, really supporting farmers on making better decisions around crop planning and management. Today, with a lot of satellite data, increasing computing power that's available, the meteorological agencies, especially in India, IMD and IITM, right? These are able to come up with very fine, finer resolution weather forecasts, right? But that is all data. How do you take that data and convert it into information advisory to farmer, right? That is kind of a gap which probably AI and ML can fill, right? So one of the first thematic areas we believe where AI and ML can make an impact is, of course, in agriculture extension. And there, a use case that I've listed here is, of course, crop planning and management. Second big thematic area where within agriculture extension is, of course, pest disease and diagnostics. I think Professor also just mentioned about, I will in fact take you through a case study of an app called Plantix with whom we've collaborated for the last 5 years as to how that app is using deep neural networks to automate plant pest disease and, identification. Another area where agriculture extension could be impacted through AI and ML is also, coming up with this idea of personalized advisories. Today, you have companies like, Kathi, I think that's the name of the company, that's actually coming up with hyper-local weather stations, which can be deployed on small farms. And the data from that could be fed into some kind of a machine learning algorithm, which would then offer very personalized advisories to farmers, right? So agriculture extension, one of the first thematic areas which could impact, which could be impacted by AI. Second thematic area is, of course, farm management. This also, remote monitoring of farms or things like automation of irrigation scheduling, especially, if you look at some of the innovations that are occurring in the realm of aquaculture, especially in the south of India, where in some states like Andhra Pradesh, where aquaculture is a big business, shrimp farming is a very big business. These are high risk and high value activities. So that's where farmers had to invest a lot of their own personal time and, deploy manpower to constantly monitor things like dissolved oxygen or, monitor the feed of the shrimps. That's where I'm seeing the early emergence of IoT-based companies that have actually managed, automate this process and make this real-time automation also. Another big thematic area is, of course, livestock. Like, there are companies like Stella Apps, then AgNext, which are increasingly coming up with wearable devices for livestock and for cows, and really supporting farmers in ensuring that they manage their cattle health better. That, in turn has a overall benefit on the quality of the milk and the productivity of the cow as well. The last area within fresh farm management that I would like to highlight is, of course, precision agriculture, which has probably been the earliest earliest manifestation of AI in agriculture. Like, this has been there for last 30 years, but some of our various reasons in countries like India, precision agriculture hasn't really taken off. Although I'm also seeing that increasingly, thanks to COVID, there are some clusters in India where the use of drones, especially for crop pesticide spraying activities, these are on the rise, especially for cotton crops and a few specific crops, right? So that's probably an adaptation of precision agriculture for the Indian context. Now, third thematic area is, of course, research, which is what organizations like ICRISAT have been doing, especially disciplines like genomics, crop physiology, or some disciplines that are, to do with technology targeting. These disciplines themselves have, increasingly embraced AI and ML to do their activities much better. So I won't go much deep into it. The fourth thematic area is, of course, around markets. This, as I think in your introduction also, Jibu, this is, one of the problems with most developing countries or agriculture in developing countries has been market failures. This has been a perennial problem for various reasons. Like you could say it's due to the, the intermediation of the supply chains or, the fragmented land holdings. There are multiple reasons, but that's where, advent of digital technologies and, AI and ML can really impact some gaps that we have in market linkages, especially in the area of price forecasting, right? And similarly, You see companies like Intolo Labs or again AgNext that are also coming up with AI and ML based solutions to automate digital grading and assaying. This is a serious problem in the agricultural marketing context in India due to the presence of middlemen. So they are also coming up with solutions like digital grading and assaying or demand forecasting. This is another probably a challenge we have in the Indian agriculture, is that inability to anticipate demand and thereby plan your crops so that you never have a situation of a glut or a shortage of the commodity. The last thematic area, which I will probably go through fast, is of course the whole concept of agriculture finance also is embracing digital and especially AI and ML in a very big way. That is because traditionally, farmers in India have always look to the informal markets for their own crop loan purposes, right? That is because the institutional finance has always found it challenging to really assess the riskiness of the smallholder farmer. That is where, with the availability of satellite technology or increasingly deploying a lot of machine learning models on top of satellite technology, and the availability of historical satellite data as well, right? So that is really enabling a lot of new capabilities for banks and financial institutions to lend to the agriculture sector. And this is also seeing a lot of startup action in India, like startups like, be it Cropin or be it SatSure, or even Government of India's own, MNCFC, the Mahalanobis Center for Crop Forecasting Center. They are also having a lot of innovation grants wherein they are engaging with a lot of startups to really, make use of machine learning and AI to improve capabilities around crop forecasting or crop loss assessment that support insurance industry. So that's a very quick overview of the broad thematic areas where I see AI and ML actually kind of blending in with agriculture. Very quickly, I will move on to a case study of this startup called Plantix, which happens to be a German startup with whom ICRISAT has been collaborating since the year 2015, right? So as I just described, this is, this particular app is free for farmers to use. It's available on Android Play Store. And what it does is the app, farmers can download the app and click the picture of a leaf or a plant. And using deep neural networks, the app automatically identifies the pest or a disease or even the nutritional deficiency that is afflicting the plant. ICRISAT, so this is a complete capability. So originally the app started purely with image recognition. It was only advising the farmers around identifying plant pests and disease. But since then they've built a whole bouquet of services around it. Like increasingly they're also offering the farmers a lot of management options. They've also added a community feature so that Plantix users can consult with each other. They've also now got a bit into market linkage space as well. But what I would like to highlight here is Plantix and ICRISAT, the collaboration is unique because Plantix is out and out a technology company. And ICRISAT, basically, we were the people who helped them, collect all the images that were used in training of their machine learning models. We also, helped annotating the images. So over a course of 5 years, we helped them collect over 1.2 million images. And today, thanks to all the images that we collected and all the annotation that we did, the app is able to identify over, 500 diseases across 50 crops. Coincidentally, in the year 2019, Plantix was declared as the most downloaded agriculture app on Android Play Store by Android themselves, right? So that's a quick overview of one such case study on what could be possible using AI and ML. I have a small summary slide here, Jibu, if I can just quickly go through it. So I have tried to list here what are some of the constraints that are probably stifling AI and ML innovation in agriculture. One is AI and ML is largely dependent on data sets, right? And as it happens, Government of India is the largest custodian of all kinds of data in this country, be it weather data, be it soils data, be it diseases data, or whatever, right? So somehow we do not have a governance mechanism using which this data can be made available to the innovation ecosystem that can probably spur a lot of digital innovation. Because that is not there, a lot of private sector money is actually getting invested into data collection, right? Which probably is not the best use, not the best allocation of the capital, private capital, right? So this is one of the first constraints that I would like to call out. Second, when you are trying to do AI and ML in agriculture, your whole approach to solving the problem has to be different. You probably have to work more in the agile mode. You need to do a lot of rapid prototyping and take a lot of minimum viable product approaches, right? So for us to really do those kinds of things, we need a lot of public institutional support and access to a lot of pilot locations, right? Coincidentally, government has the largest social infrastructure to enable this kind of a support for startups or for any of the actors in the innovation ecosystem. Third, I believe that in the realm of AI and ML in agriculture, innovation has to be a lot more bottoms up because as such, agriculture in India is very, very heterogeneous. There is so much of diversity in our farming system. You can't take a solution that works for a big farmer in Europe and try to, force fit it back into the Indian context, right? So innovation in India has to be largely bottoms up innovation. So we need lots of startups, lots of government support at the last mile, and lots of grassroots institution to support that innovation. Last but not the least, we need a lot of risk capital and public money that needs to go into high risk projects, right? So government has to somehow figure out a fine balance on what are the kind of projects that they support vis-a-vis the kind of projects that private capital will be able to address. So that was my last slide. I will stop there and leave you with these quick thoughts. Thank you.
Thank you, Ram. That's quite insightful. And I want to add something to Ram. I mean, there have been so many innovations that are happening in India currently in the AI startup field with regard to agriculture. Some of them Ram has mentioned, such as AgNext, Cropin, and others. Similarly, there is a startup called AquaConnect who exclusively focus on the shrimp farmers. And from a government perspective, I think the government, as Ram pointed out, for the crop, the credit part of the agriculture, the remote satellite data is being used for the farmer credits and for as well as for insurance purposes. I think services of Cropin is being used by Pradhan Mantri Fasal Bima Yojana, which is a farm insurance project, as well as we have seen so many initiatives, pest reduction projects and things happening. On the other note, with regard to data, he has an interesting point. And from my knowledge, there have been work going on right now to create a bigger availability of publicly available data sets, which I think will happen soon. So if you have any questions regarding AI and agriculture in India, you can go to India AI and you can see them all. Now, coming to questions, we have so many questions. So I will start with Sonoko. So I have two questions to you, Sonoko. The first one is about the type of data that you've been using. So the question is, are you using hyperspectral images or multi-temporal remote sensing, satellite data? That's one question. And second is all the data you use for the training purpose in the DAAD project, are they exclusively based out of Europe, or is it from any other region?
Thank you very much. Yes, we are using multispectral data from UAVs to analyze plant growth and to have this. Our idea is to segregate the field into smaller patches, and for that we use also the data of multispectral cameras on the field. We use remote sensing satellite data for using in a larger scale the heterogeneity of the landscape. And there we go back in the past to check the NDVIs and other characters, also landscape elements like trees and bushes and shape of a field to analyze the development of the structures. Yes. And for our cases, we are just developing for Germany, but in Germany, there are also large heterogeneities. So in northern areas, the fields are large, so there are 100 hectares, one field. And in southern parts, there's a much smaller field. So we have two sides to compare that the methodology we develop here is applicable for different sizes. Unfortunately, I don't have any project in India, but in several other Asian countries like in China or Japan, we have collaborations where we apply also this method. The data cannot be used, but this approach can be used.
Thank you, Dr. Sonoko. Now coming to Dr. Sebastian. So there is a question by Gaurav Sharma. And before I get into the question, Gaurav, Nalamki is more of a platform, while the comparison you have made in your question to Vadwani is a case-based initiative they've been doing. So the question is, how scalable is Nalamki for a particular crop? So he's asking about that, and also he's wondering if it can be another question from Manik, Dr. Manik, is can it be modeled to develop region-specific farmers advisory for specific seasons and crops? So these are the two questions that I think you may be able to answer.
Yeah, thank you for the questions. Both of them are very good questions. So regarding the scalability to other crops, so what we are developing here is basically a very general approach. So let's say we have this platform in the production, right? So even then we are still growing in terms of methods, as we plan to allow third parties just to plug themselves in there. And in our use cases that we are basically using as some sort of proof of concept, we are certainly limited in our in the selection of crops that we are using. But we believe that the methods with regard to the data acquisition, but also with regard to the methods, so the algorithms, are very much applicable to other crops as well. Modulo some restrictions or some adaptations with regard to the physics of the crops, like different basically tree anatomy, so to say. So that's the one thing, and the other thing was regarding. Can you remind me of that, Jibu? So the second question was with regard to.
Yeah, second question. Actually, the question was regarded to model specific regional advisory.
Yeah, absolutely. So we want to have every farmer have a local AI, so to say, that is specific. It's based on a general model, but it's specifically geared towards the requirements of this specific farm. And this takes into account the selection of crops that is specific for this farm. Not every farm has the same sort of products that are produced there. So that's one thing where we are steering our models towards the specificities of single farms. And then the other thing is that the models are adapting to the local geographic and climate-related aspects there as well. So yeah, so that's one part of the goal that is basically born out of this farm-based model architecture.
Thank you, Dr. Sebastian. So another question is we are getting is more about soil science. I think Sonoko will be able to answer that better. So the question here is what way I think the DAAD platform or platforms help to have information regarding soil science, and what are the parameters covered when it comes to soil?
Yeah, soil quite a lot. We focus first on the erosion, so it's the protection of the soil, but also on there will be other indicators, carbon sequestration that can be related to greenhouse gas reduction, as well as for soil fertility. There can be also on water retention. You may have heard about the flood in Germany, so there will be also the retention, as well as for the drought period. It's also a big issue on the climate change. So it's for both sides, we have a buffer in the soil. So it is not it's the soil itself, so it is a certain limit, but in the landscape that there is a buffer for water. So it reaches out from soil, from particles to the landscape. So that is also our approach, that we look into different spatial scale. And anyway, there will be these indicators. There are also, of course, about the fertility itself. So again, related to also erosion, carbon stock at soil, but also on the nutrient cation exchange capacity. Another issue will be leaching, so it will be the buffer for nitrate, nitrogen. So nitrate pollution in the underground water, it's one big issues. Yeah, can be also, and one thing which is often lost is the biological aspect. So the soil and chemical, physical and biological aspects. So the biological aspect, that there is enough earthworms and other soil animals, is also one important indicators.
Thank you, Sonoko. So another question which has been asked by many of our participants. So I will give this question to Ram. So they want to know what are the downsides of AI, right? On using that, we've been always talking about the good side. So for example, one of the questions we got is, detection and correction of plant health is very promising, but what are the known and unknown risks involved in this empowered decision making? Maybe Ram, you can take this up.
Sure. Yeah, I mean, one thing is obviously any sort of a digital tool for farmers will naturally disadvantage those farmers who are not digitally literate, right? So there are possibilities. Sometimes it also creates new power centers. It creates, like, let me take the example of Uber, right? It basically dislodged the incumbents, but it also in some ways is becoming very powerful, right? So the characteristic of any digital economy is it has a tendency to create alternate new power centers. There is also centralization of power. So this is a phenomenon. But having said that, if you look at the social science research within digital agriculture, there is some emerging scholarship in the area of responsible innovation, right? So there are some scholars who are extensively writing about the need to, to embed responsible innovation, especially, as digitalization is becoming more widespread in agriculture. In fact, there are a couple of interesting papers that have emerged from Australia. So scholars are also, underpinning or, emphasizing the need to build the capacity to foresight. That is, our ability to. So right now, what happens is a lot of the policy apparatus, probably lacks the ability to foresight. Like if you bring digitalization, how would the whole, how will things pan out, right? Who will become powerful or who will be disadvantaged? We probably lack that foresighting capabilities. That's where there is emerging scholarship, especially from social sciences on, trying to foresight what could be the trajectory of digital agriculture. And if you are able to, foresight that trajectory, how do you then incorporate responsible innovation so that end of the day, AI actually leaves us with a far more equitable agricultural development rather than, transitioning from, a one scenario to another scenario where you're just dislodging the incumbents and you're replacing with a new set of players. So that's kind of my slightly more abstract answer to that question.
Thank you, Ram. So we have another question for Sebastian. So Sebastian, you mentioned about how the Nalamki project is engaging with multiple partners, right? The university, the industry, like John Deere. So the question is, can you throw more light on the engagement with various partners, especially focusing on insurance companies and others in that area?
So for the partners, I think the question here is, what are the specific interests of the partners? And obviously for a player like John Deere, but also other industrial partners, they want to build a product out of this project, which is fine. And for us, like the research facilities, also the universities, the main interest is here to do research and to generate basically knowledge about the processes that are relevant for AI in agriculture. And this comes together because we are sort of relying on the industry here because of two reasons. So the first reason is basically that we are, most of the engineers are expert and scientists are experts with regard to methods, to algorithms, to AI, but not so much with regard to the specific domains in which we want to apply our methods, right? And so for us, it's very important to have these partners in the project just to get informed about the real world problems that are out there, because this avoids the risk for us to basically do interesting research without a use case. So we need these partners from the application domain to be sure that the use case that we are addressing is actually a use case that is relevant. And then the other reason why these partners are very important for us is that they make sure that our research actually gets traction and will translate into practice. So that's the two reasons why partners like John Deere and other industrial players that we have there are very, very important for us. Does this answer your question?
I think so. So another question, I think both Sebastian and the Sonoko can answer this. The initiatives, both these initiatives, the DAAD project as well as the Nalamki, they're quite exciting and things that have been happening. So my question here is, how do you see these projects? What is the scope of this project being replicated elsewhere other than particular geography? Because then the whole data sets need to be changed, right? The geography is different, the environment is different, the climate is different, right? So many parameters needed to be changed. So what are the potential in which these can be replicated, let's say in a country like India?
I think that this approach, at least the Lamki project, is very much applicable to other regions as well. So, I mean, what we are sketching out there is a very, very general approach. And I think of it more like a sort of mobile, so where you can just plug stuff in. And some of these things that we're plugging in there, some of these technologies, they might incorporate some sort of domain knowledge and domain models that are very specific for a certain region. But I believe that those can be adapted. Most of the stuff is going to be mostly data-driven. And then once you have the data, you can just basically apply it anywhere you want, as long as the data is somehow catching and representing what you want to model.
So, I mean, same question to Sonoko. How can we expand something like DAAD's project across geographies? What are the potential?
Thank you very much. I would also say that it can be same for applicable to anywhere. Of course, you need the data, but even in Germany, we need this whole data set. We have now 2 sites in Brandenburg, northern part, and Bavaria. If you go to any other region in Germany, we need the same process, that we gather the data and compile the data set. So it will be the same for anywhere in the world. In our case, it would be specific that there will be the farmer's choices and a farmer database should be reflected. So in this case, this part that the farmer should input, it depends on how digital this farm information are already. Otherwise, the farmer should put in more information to have a more specific answers to his farm unit. It depends also what you are growing already and what are the machineries, facilities. So this information should be coupled. But we're also developing different data sets that we don't need this specific information. Like in Germany, they are high-tech machines. They record all the harvest data on the field. So if you don't have this kind of data, how to replace them with satellite data and other data, we are on the way to develop also to make it applicable to also other kind of data sets.
I think as technology improves, we might be able to, like Sebastian has pointed out, with technologies like federated learning, we will be able to replicate this same models, across many geography. And since we were talking about data and, we are running out of time, a final question for Ram. Ram, and we have discussed about the issues with data. And I often hear this quote when it comes to India, right? India is data rich and technology poor. So, and the same thing here is happening with the agriculture field also. So how do you think we can overcome this challenge, taking inputs from what Sonoko and Sebastian has been doing, right? How can we address this data problem in India, especially with regard to agriculture?
I mean, as I've also tried to summarize in my last slide, I do not know how much I agree with that quote. India is data rich. I think we are a data scarce society. Even if you look at the agricultural statistics in the way we collect our agricultural statistics, it's largely a sampling based approach, right? Because it's largely been manual. We do not have the human resources or the institutional capacity to be able to scan every farm. We largely rely on a sampling approach. But my own thinking, or it's slightly, you can say my idea is utopian. But I think for us to really make use of data-driven agriculture, or to really, actualize AI-based agriculture in its truest sense, is we really need to percolate the human capacities of using AI almost to the last mile, right? So you need to have small, like you see, as I said, agriculture in India is very, very diverse, right? Just like the languages and the customs And I think you also mentioned in your introduction that somehow agriculture and our traditions, somehow they are intermingled, right? For instance, a lot of farmers, even they use the traditional almanac that, each state releases, to plan their agricultural operations, right? If that is the level of contextualization and so much of localization that is existing in our agricultural practices, and if you are really speaking about bringing in a technology like AI or bringing a data-driven approach to decision making and stuff, so we really need a lot of local innovators who have the capacity to to really use AI and ML, right? So in that sense, innovations like cloud or all these cloud, which are today truly democratizing AI and ML, we need to have a lot of local innovators who really understand the local problem and then figure out how to use AI and ML to solve that local problem and still be able to create a sustainable business. You can't think of a centralized model and then trying to do a big bang approach and hoping that everybody in India will adapt. So this is slightly my own idea that you need a lot of localized innovation. For that to happen, you need a lot of local innovation, a lot of capacity at the last mile. So I'll put it that way.
So that means you need a lot of local data as well, right? Rather than a larger national level platform, right?
Exactly, Jibo. And so when I say a lot of local level data, it is the local innovators, right? So I'm an entrepreneur in my village. I understand the practices. I know the data better, right? So if I have the capacity to embed or use AI, ML and solve a local problem, which is very real for the farmer, that's where probably you'll get a lot of traction.
I think Sonoko and Sebastian, I mean, since we are, this is a Indo-German collaboration, what do you like to add to the problems that, some of the real problems we are facing in India that Ram has mentioned? How do you think, maybe a platform like yours can bring a solution, or in your opinion, what will be a way we can address these challenges? Dr. Sonoko?
Yeah, it would be, I think, even though the area and some magnitude are different, we face similar issues. And I don't think that this AI is farm size dependent. Of course, the data should be available, so it is a kind of a matter of resources, so should be available. But if there are public data available, the farm size does not matter. So we are analyzing this also in Germany. In this case, we have quite similar issues, and the method we are looking for, so it's the talk about RAM also inspired me, are quite similar, so we can, collaboration may move us both forward to solve the problem much more dynamically. So I really, hope we can work together.
So, Dr. Sebastian, how do countries or economies like India address this data issue, where there is no proper data infrastructure to create something like the Nalamki project?
I don't know. And to be honest, I think so I totally agree with Ram and Sonoko, because I believe that we actually have the same problem in Germany. So data is not scarce. And I think the same applies to India. Your data, I don't think that it's scarce. What's scarce is the annotations. And there are some approaches that try to work on models that are not relying on annotations anymore, self-supervised learning, stuff like that, semi-supervised learning. There are approaches like that, but they are in the infant shoes, so to say, and I'm not sure if they work out. So I don't believe that we find a way that sort of bypasses this annotation problem. And this is a problem that you obviously face in India, but we face it in Germany as well. So if we want to generate data, annotations, then this is a very, very tedious task. And the problem is different to other like ImageNet, like MS Coco. There are a lot of toy databases out there. When it comes to real data, then you face basically two problems. One problem is we assume that the data acquisition itself works. So we have a lot of data that you just need to annotate, but then you want to make sure that the annotation process is really of a quality that's high enough. So you don't want to have a lot of label noise, because you want your models to work in real life, which is much more complicated than in the lab. And the second thing is to actually generate the data, you need domain knowledge. So if I were to, let's say, segment an elephant and a giraffe, every kid can do that. So that's a very simple task, and you can crowdsource this to wherever you want. So their data annotation is very easy, straightforward. Even there it's complicated. But when it comes to systems that are to be employed in the real world high-stake domain like agriculture is, then you want your data labels to be provided by experts, because other people just don't have the domain knowledge. I'm not able to distinguish this fungus from another fungus, but it might be important because you want to apply the right pesticide there. And I think that is one of the major challenges that we are facing. And with regard to the Nalamki process project, so we are sort of hoping that because this is something that DWIH actually allows, that we will be able to build up some sort of marketplace where people with domain knowledge can actually trade annotations as well. And that might be a way to circumvent this issue of annotation scarcity.
So I think this idea of having data marketplace, I think this is being started. There is a project in India called IUDMX, so it works with smart cities. So what it does is, in a smart city, you have this data sitting in different silos, right? You have the fire data with the fire department, you have the crime data with the police department, and the weather data, education data with the schools. So they created this, it's in an early stage. They created this platform where these data, they act as a middleman or a provider, and they standardize this data, and it's like a pipeline, and you can access this data for a cost, right? I mean, there should be an incentive for the person who is sharing this data, right? So I think do you think the future will be similar platforms where you will be encouraged to share the data, like data market or exchanges where you will be encouraged to share data for a particular reward, particular cost, something like that?
I hope so. I think this is a question that is far beyond the scope of this web talk, to be honest, because this is a political question as well. So the DWIH project, which is very central to our Nalamki project, that's a political initiative, right? That sort of tries to build an infrastructure that complies to the European values of data sovereignty and stuff. But this is a clear project that is clearly, maybe you can even say, opposed to the hyperscaling approach that you find in the US, for example, Google, Amazon, Microsoft Azure, all these things, where you have data silos that combine everything and you lose basically your data sovereignty. So this is a project that tries to build an alternative that, as I said, complies to European values. And if you have such an approach, I mean, then you have an open system, an open platform, and everyone who complies to these regulations can do whatever he or she wants. So then it might be a good way, yeah.
And one more question, please feel to chip in, our panelists, is that we have a very few, how do you say, aspiring entrepreneurs and students in the group, and they've been asking which are the open source data sets they can refer to, right, for their own projects and other purposes. Any sources which any of you want to mention?
To be honest, I cannot provide here anything more than a Google search would reveal. So,
what about DCRISAT? Is there? I think there are some data sets made available to the public, isn't there?
Yeah. So apart from that, we are compliant with the open data policies. So a lot of research and the publications that we come out, most of our data sits in the open domain. Now it's a different matter. How much of that data will be used for the use case that the startup or the entrepreneur in mind is a different matter altogether, right? But yeah, if for someone interested, there are tons of data sitting, like FAO has lots of data on the public domain. There's a lot of World Bank data, but depends on the use case. What is it that you're trying to do?
And also there is a open data.gov.in platform, and I think some of the states in India has a data platform. I think Telangana has a lot of weather data and some crop data in their data platform. So closing, let's it's a pleasure to have you all here. It's very insightful. Any closing remarks, Sonoko, Sebastian, Ram, with regard to this? Any last statement you want to make? Okay, I guess that's it. Thank you all. It was very good interacting with you, and I hope our participants also have taken a lot of value from this web talk. And I'm wishing you all the best, Sonoko, Sebastian, and Ram, for your projects, and I hope it will you will bring more success to you and may be able to touch more people's lives through these initiatives. Thank you, everyone, and thank you for the participating. If you have more questions, I think you can connect with the social media handle of the host social media handle, or you can look up the panelists here or me in some of the social media, right? And also don't forget to check out the web talks tomorrow on AI in healthcare, and another one on Wednesday on AI in education. Thank you all. Thank you.
Thank you.
Thank you.